Welcome to Homework Help with Dr. Morgan. Today we're going to be looking at the homework help for worksheet 1-1 in Math 1. Remember, these are similar problems. They're almost exactly like the problems in your homework. So if you're having problems with one of these homeworks, look at the explanation here and you should be able to see the pattern on how to work the homework on your for tonight's homework. Today we're looking at expressions on just simplifying expressions, not equations, just expressions. And one of the ways we can do this in the first one is use the distributive property. You remember the distributive property? The distributive property says that if I take a number A and I multiply it by a sum like B plus C, I can multiply the A times the B and then add the A times the C, and those are equivalent. It works also if this were B minus C, and sometimes you can even go backwards, but that's our basic. So what we want to do here is simplify using the distributive property. So first thing I'm going to do is multiply 5 times D and then plus 5 times 4. Or if I simplify that, that's 5D plus 20. Okay. Next one, notice all we did different on the second one was we have it in reverse order. We have this times 7, but I'm just going to do the same thing. I'm going to go 7 times 4, and that's 28. I'm going to put my subtraction sign down, and 7 times x. And that's my answer. Not too bad. Number C, 1/4 times 8. So I'm going to have 1/4 times 8y minus 1/4 times 24. If I want to make this into a fraction, I want to put these together. Remember, this 8y could be 8y over 1. Subtract and multiply the numerators. You get 8y. Multiply the denominators over 4. Again, I could do this too, and I get minus 24 over 4. And now 4 goes into 8 2 times, so this is 2y. And 4 goes into 24 6 times, and so my answer is 2y minus 6. Simplifying the expressions here, this is actually kind of like, these expressions division are kind of like the property. And I'll show you here. I could write this, for example. Dividing by 4 is the same as multiplying by 1/4, multiplying by the reciprocal. You may remember that division is the same as multiplying by the reciprocal. So I could actually write this way. And you notice then if I do my distribution, I get 1/4 times 7x plus 1/4 times 5. If I change that into fractions, I get 7x over 4 plus 5 over 4. Okay? And that's one way to look at it. Change the divide by 4 into multiply by 1/4 and apply it. Well, once you sort of see that pattern, though, you can start making this a lot easier and just think of this problem here and think of, I'm just going to divide each of them by 4 and go, okay, I'm going to have the 7x divided by 4 plus the 5 divided by 4. And notice that's exactly what we got right there. Once you see that, instead of doing all of this at the bottom, you can just come up here and go, oh, okay, 4x plus 9 divided by 3, that means the 4x gets divided by 3, and then the 9 gets divided by 3. This time we have to simplify, because 9 divided by 3 is 3, so our final answer is 4x over 3 plus 3. Once you see this, it can be very simple. Okay, again, I'm going to take the top, and each one of them gets divided by 5. So I have 15 divided by 5 plus 10x divided by 5. 5 goes into 15 3 times, and 5 goes into 10 2 times. So my answer is 3 plus 2x. See that? So doing this way is simpler than doing it that way, but it's helpful sometimes to understand the other way as well. In this case, we have a simple problem where we're multiplying by, this is the same as, and I'll write this one here, this is the same as negative 5y minus 7x is the same as negative 1 times 5y minus 7x. So if you multiply through there, distribute, negative 1 times 5 is going to be negative 5y, and then subtract, and then negative there is negative 7x. But notice that this becomes then minus 5y, negative, the opposite of a negative is positive 7x is your answer. Okay? So you're kind of multiplying by negative 1, or you can think of it as being the opposite. If I come up here and I say, what's the opposite of 5y? The opposite of 5y is negative 5y. And then I could look at this, instead of subtraction, I could say, okay, what's the opposite of negative 7? Well, the opposite of negative 7 is positive 7x. And notice that's exactly what we got down here. And so that's a helpful way to do this with the opposite. Think of this negative sign here as being the opposite of everything inside the parentheses. What's the opposite of m? Well, the opposite of m is negative m. What's the opposite of 9? Negative 9. And there's our answer. Now here they're just trying to make it a little more complicated by putting more stuff inside. But let me just see. What's the opposite of negative m? The opposite of negative m is positive m. What's the opposite of 8n? The opposite of positive 8 is minus 8n. And then what's the opposite of minus 11? Plus 11. And there's our answer. So that's just a simple way of seeing. Again, you can look at it as if you're multiplying by negative 1 and multiplying through, and that works. But a simple way is to just think, what's the opposite of everything inside there? The other way that we simplify expressions is by finding terms that are like terms and putting them together. Now, like terms are terms that have the same exact variable part. They may have a different numerical coefficient, but they have the same part. So, for example, a simple example, 2x and 3x have the same variable part. They both have an x. So I can actually combine these and say 2x plus 3x equals 5x. Think of the variable part being a piece of fruit. 2 apples plus 3 apples is 5 apples. It doesn't matter what the variables part, they just have to be the same. So for example, if I had 2 xyz and I had 3 xyz, the variable part's the same, so those can be added together. What you can't have is you got to be careful, especially with exponents, if they're not the same. If I had 2 x squared y plus 3xy squared, you might look and go, well, there's an x and a y and a square. But notice this is x squared, whereas this is y squared. So I can't add those together. They're not the same. Okay, those are not the same terms. So let's look up here at our first problem. Let's look for things that have the same variable part. First of all, notice that the 6 and the 2 do not have any variable, but that makes them actually like terms. Likewise, here, the x and the x are the same, so these can be combined as well. Now, if you want to, you can use the commutative property to get them next to each other. Like I can switch these two here and write it as 3x minus 7x plus 6 minus 2. Now, in theoretical terms, often what a person is supposed to do here is to do the reverse of the distributive property and say, well, this is x times 3 minus 7 plus 6 minus 2. And then I can say this is x, 3 minus 7 is negative 4. And this is 6 minus 2 is 4. And so I can end up writing minus 4x plus 4 as the answer. However, while that's theoretically how we do it most precisely in math, the easier way is just to look and go, okay, what's 3x minus 7x? 3x, look at the numbers, 3 minus 7 is negative 4x. And then what is 6 minus 2? It's 4. And so we get the answer that way. I'll show you how that works on the next one. Let's just, instead of doing all of this work here, let's just find the common terms. There's a 2x and a 9x. They both have the same. What's 2 apples plus 9 apples? Oh, that's 11 apples, or 11x. And then I have a negative 3y and a negative 4y. So think, what's negative 3 plus negative 4? That's negative 7y. And you see, we actually, in our head, we're doing all of this other work, but we can do it directly. Now notice here, I have an x squared y. Well, where's the other x squared y? Notice this is y squared, so that's not the same, but here's an x squared y. So I can add these two together. 6x squared y plus 3x squared y. 6 and 3 is 9, so that's 9x squared y. This one is not the same, so I just have to leave it. I can't simplify it anymore. And so there's our answer.